Hi guys, welcome to Church Channel. Before we get started, make sure to hit that like button, also subscribe to my channel. Top 50 mysterious things about the Trappist system, so make sure to watch the full video. 1. How did the Trappist 1 system form? Despite being a relatively common type of star, dwarfs like Trappist 1 are thought to have lower metallicity, meaning they contain fewer heavy elements that are necessary for planet formation. This raises questions about how such a system could form with so many Earth-sized planets. 2. Is Trappist 1 a relatively young or old star? Determining the age of Trappist 1 is difficult due to its low mass and dimness. However, understanding the age of the star can provide important clues about the formation and evolution of its planetary system. 3. How stable are the planetary orbits in the Trappist 1 system? The proximity of the planets to each other and the star raises questions about the long-term stability of their orbits. 4. How much water is present on the Trappist 1 planets? Water is a critical component of life as we know it. 5. Do the Trappist 1 planets have atmospheres? The presence or absence of an atmosphere can play a significant role in the habitability of a planet, as it can affect its surface temperature, the amount of radiation it receives, and its ability to retain water. 6. How do the Trappist 1 planets compare to Earth in terms of their geology and tectonic activity? Understanding the geological processes that shape planets is important in determining their potential habitability. 7. Could the Trappist 1 planets have magnetic fields? Earth's magnetic field plays a crucial role in protecting life from harmful radiation from the Sun. 8. Is Trappist 1 a flare star? Flare stars are known for their violent eruptions of energy that can impact the habitability of planets in their orbit. 9. What is the surface gravity like on the Trappist 1 planets? The surface gravity of a planet affects its ability to retain an atmosphere and can impact the development of life. 10. How do the Trappist 1 planets compare to other exoplanets discovered so far? Studying the Trappist 1 planets in comparison to other exoplanets can provide important insights into the diversity of planetary systems in the universe. 11. What is the composition of the Trappist 1 planets? Determining the chemical makeup of the Trappist 1 planets can provide clues about their formation and evolution. 12. How do the Trappist 1 planets compare to the inner planets of our solar system? Studying the Trappist 1 planets in comparison to Mercury, Venus, Earth, and Mars can provide important insights into the formation and evolution of rocky planets. 13. Could life exist on the Trappist 1 planets? While the Trappist 1 planets are located in the habitable zone, it is not yet known if they have the necessary conditions for life to exist. 14. Are the Trappist 1 planets tidally locked? Tidal locking occurs when a planet's rotation and revolution are in sync, causing one side of the planet to always face the star. 15. How do the Trappist 1 planets compare to the outer planets of our solar system? Studying the Trappist 1 planets in comparison to Jupiter, Saturn, Uranus, and Neptune can provide important insights into the diversity of planetary systems in the universe. 16. How long do the Trappist 1 planets take to orbit their star? Understanding the orbital periods of the Trappist 1 planets is important in assessing the stability of their orbits and their potential habitability. 17. How do the Trappist 1 planets interact with each other? The proximity of the Trappist 1 planets to each other means that they are likely to have gravitational interactions that can affect their orbits and potentially impact their habitability. 18. What is the temperature range on the Trappist 1 planets? Understanding the temperature range on the Trappist 1 planets is important in assessing their potential habitability. 19. What is the atmospheric pressure like on the Trappist 1 planets? Atmospheric pressure can play an important role in the habitability of a planet, as it can affect its surface temperature and ability to retain water. 20. How do the Trappist 1 planets compare to exoplanets discovered by the Kepler mission? The Kepler mission was designed to discover exoplanets and study the Trappist 1 planets in comparison to those discovered. 21. How do the Trappist 1 planets compare to the planets in our solar system in terms of their size and mass? Studying the Trappist 1 planets in comparison to the planets in our solar system can provide important insights into the diversity of planetary systems in the universe. 22. Could the Trappist 1 planets have moons? The presence of moons can have significant impacts on the habitability of a planet, as they can affect its tides and potentially provide a source of liquid water. 23. What is the surface temperature like on the Trappist 1 planets? Understanding the surface temperature on the Trappist 1 planets is important in assessing their potential habitability. 24. How do the Trappist-1 planets compare to the rocky moons of our solar system? Studying the Trappist-1 planets in comparison to the rocky moons of our solar system can provide important insights into the formation and evolution of rocky bodies. 25. How do the Trappist-1 planets compare to the gas giants of our solar system? Studying the Trappist-1 planets in comparison to Jupiter, Saturn, Uranus, and Neptune can provide important insights into the diversity of planetary systems in the universe. 26. What is the radiation environment like on the Trappist-1 planets? Radiation can have significant impacts on the habitability of a planet, as it can affect the chemistry of its atmosphere and potentially harm living organisms. 27. How do the Trappist-1 planets compare to other potentially habitable exoplanets? Studying the Trappist-1 planets in comparison to other potentially habitable exoplanets can provide important insights into the potential for life to exist in the universe. 28. What is the composition of the Trappist-1 planets? Understanding the composition of the Trappist-1 planets can provide important clues about their formation and evolution. 29. What is the magnetic field like on the Trappist-1 planets? A planet's magnetic field can protect its atmosphere from being stripped away by stellar winds, which is important for the long-term habitability of a planet. 30. What is the surface gravity like on the Trappist-1 planets? The surface gravity of a planet can affect the atmosphere, geology, and potential habitability of the planet. 31. What is the level of volcanic activity like on the Trappist-1 planets? Volcanic activity can have significant impacts on a planet's atmosphere and potential habitability. 32. How do the Trappist-1 planets compare to the moons of the gas giants in our solar system? Studying the Trappist-1 planets in comparison to the moons of Jupiter, Saturn, Uranus, and Neptune can provide important insights into the formation and evolution of icy bodies in the universe. 33. What is the level of geological activity like on the Trappist-1 planets? Geological activity can have significant impacts on a planet's surface and potential habitability. 34. How do the Trappist-1 planets compare to other multi-planet systems discovered by the TS mission? The TS mission was designed to discover exoplanets and study the Trappist-1 planets in comparison to other multi-planet systems discovered. 35. Could the Trappist-1 planets have rings? The presence of rings can have significant impacts on the habitability of a planet, as they can affect its tides and potentially provide a source of material for moons to form. 36. How do the Trappist-1 planets compare to the moons of Saturn in terms of their size and mass? Studying the Trappist-1 planets in comparison to the moons of Saturn can provide important insights into the formation and evolution of icy bodies in the universe. 37. What is the level of seismic activity like on the Trappist-1 planets? Seismic activity can have significant impacts on a planet's surface and potential habitability. 38. How do the Trappist-1 planets compare to the planets in our solar system in terms of their density and composition? Studying the Trappist-1 planets in comparison to the planets in our solar system can provide important insights into the diversity of planetary systems in the universe. 39. Could the Trappist-1 planets have oceans? The presence of oceans can have significant impacts on the habitability of a planet, as they can provide a source of liquid water and potentially host life. 40. How do the Trappist-1 planets compare to the moons of Jupiter in terms of their size and mass? Studying the Trappist-1 planets in comparison to the moons of Jupiter can provide important insights into the formation and evolution of icy bodies in the universe. 41. What is the level of atmospheric escape like on the Trappist-1 planets? Atmospheric escape can have significant impacts on a planet's potential habit. 42. How do the Trappist-1 planets compare to the dwarf planets in our solar system? Studying the Trappist-1 planets in comparison to Ceres, Pluto, and other dwarf planets in our solar system. 43. How do the Trappist-1 planets compare to the rocky planets in our solar system in terms of their size and composition? 44. What is the level of radiation exposure like on the Trappist-1 planets? Radiation exposure can have significant impacts on the habitability of a planet, as it can affect the development of life and the stability of a planet's atmosphere. 45. How do the Trappist-1 planets compare to the exomoons discovered by the Kepler mission in terms of their size and composition? 46. What is the level of atmospheric pressure like on the Trappist-1 planets? Atmospheric pressure can affect the climate and potential habitability of a planet. 47. How do the Trappist-1 planets compare to the planets in our solar system in terms of their distance from their star? 48. Could the Trappist-1 planets have magnetic fields? The presence of a magnetic field can protect a planet's atmosphere from being stripped away by stellar winds, which is important for the long-term habitability of a planet. 49. How do the Trappist-1 planets compare to the exoplanets discovered by the Kepler mission in terms of their size and composition? 50. What is the level of tidal forces like on the Trappist-1 planets? Tidal forces can have significant impacts on the habitability of a planet, as they can affect its tides and potentially host life in ocean worlds. What do you think of our video? Let me know in the comments section below. If you enjoyed this video, make sure to hit that like button. Also, subscribe to our channel before you go.